Everyone, I see people are still dripping in a little bit. As Ian already mentioned this morning, it's indeed been 3 years already since both the first time and the last time that I was on stage at the bSDD Summit. So a lot has happened in the last 3 years. I thought I'd indeed start with a proper introduction of myself again. So my name's Léon van Berlo, 44 years old. I have 2 kids, 7 and 9 years old. Like I think half of this room, I'm from the Netherlands. So I like to eat pannenkoeken. I think that's an important statement today. I like cycling. This is me in one of my cycling kits. Unfortunately, there's no buildingSMART cycling kit yet. Come on, can we arrange that somewhere this week as well? Yes, thank you. I see all are very enthusiastic here in front. So this fighting assumptions term is the motto, is a catchphrase of my investment company. I had some companies before I joined buildingSMART. I still have an investment company, and this fighting assumptions is kind of the motto of what the company stands for, but it also represents me. It's also a little bit what I'm standing for. It's really about looking at where is the value. I'm kind of trained to look for value in the last couple of years, and often you need to look a little bit deeper and a little bit further. But that's really what drives me most of the time. I am not religious. All respect for people who are, so not against religion. I'm just not religious. That also explicitly includes the openBIM religion. I'm not a dogmatic follower of the openBIM religion. I'm not telling everyone to put their data in the bSDD because you must do. Again, I believe in value, and I strongly believe, I do have beliefs, it's not a religion, but it's a belief that a lot of our open standards and solutions really do add value to the industry. And that's what this session is about. I have a reputation to be impatient. I always thought that was true. Actually, quite recently, I learned that I can be in line for a very long time as long as I see that at the end of the line, something very efficient happens. But being shorter in line to wait for an inefficient process really gets under my skin. When I explained this to my wife, she said, yeah, you have a point, but I still think you're impatient. So take this one with a grain of salt. But it's really this search for value and not really liking inefficiencies or looking at inefficiencies is also what drives me in this role. And the best example of this, I think, is my sock drawer. Also, my wife was wondering why I took a picture of that, but let's get to that. I'm sure you all know the feeling of processing socks when they come out of the laundry. Getting the two that match together, one is always lost. When one gets broken, the other one is still there. It's such a waste of my time. It's kind of time that I can't get back in my life. So it's about, I think, maybe 10 years ago already that I just threw them all out, and I went to the HEMA, also typical Dutch thing. I bought 20 pairs of the same socks, and now every time they come out of the laundry, I just pile them in the drawer. It's perfect. Every time I do this, I get reminded on how short life is, and I spend more and more time with my family again. Every time I do socks in my drawer, I spend time with my kids. So in my head, there is a very clear relation between what I do in investments, how I treat my socks, and also in the role as technical director. So I had a very different life before I joined buildingSMART. So I gave up quite a lot to really try to add value for the industry. And I think that when we add value for the industry, we also do the best thing for buildingSMART. So when I joined, I gave up quite a lot. There were 5 big topics to challenge. I think we're about halfway now. We published a roadmap for 5 years, 5 big topics. We're 2.5 years in. I think we have 3 topics relatively done, working on a 4th one. So relatively on schedule. That said, the efforts to drive these 5 major changes have obviously been very intense. This is not a nice job. That's for something that I knew for sure after these 3 years. There's recently I looked back this movie Philadelphia, and there was a scene in there. Let me see if I can quote this correctly, where Andy takes the stand and he's being asked, "What do you love about the law?" And he says, "Every now and then, not often, but occasionally, you get to be part of justice being done. That's really quite a thrill." And when I saw that, I kind of projected that on my job. It's a shitty job, really. There's a lot of resistance. There's also a lot of people that push that we need to change faster. So you're kind of stuck in the middle. There's a lot of travel away from the family. I'm not even going to say something about what it pays. It's there's a lot of other things that you can do. But every now and then, not often, but occasionally, you get to be part of a massive change of the industry, really adding value to the industry. And that's really quite a thrill. And the nice thing is also that when you get inside that industry, so away from the openBIM church or synagogue or whatever we call this here, really in the industry, talking to those people, see how they add value, how they use the open standards. It's really quite a thrill. And that's what this session is about. So this adding value with openBIM workflows is basically an invitation of all of those people who invited me in the last couple of months and years, sometimes just to show what they did, sometimes very politely saying, "Yeah, we did something and we just want to know if we did it correctly," and then they show off something really amazing. Those people are going to be on stage today. Those people are going to share what kind of value they get from using openBIM standards and solutions. So let me introduce them to you. Side note, if you want to see the workflows that these people have been using, how things connect with bSDD and BCF and OpenCDE, we've got very, very detailed workflows made by Evandro. Again, they're very detailed, but they are out there, so if you're interested. Dumbing down those very detailed workflows, we get to this part. There's basically 4 big blocks. It's about defining information requirements, authoring data, validating data, and sharing. So the first presentation, I'm going to go over all of them, so no hurry yet. First presentation is by Min Song and Rick Klooster on defining information delivery specifications and validating those. So Min and Rick have been doing that on a couple of projects. I think they showed 2 projects and 1 other use case. The presentation after that is from Stijn van Schaijk and Jan Brouwer, who are leveraging the buildingSMART data dictionary together with IFC to automate a lot of really cool processes. Third one will be a live virtual one, so this is not pre-recorded but live, from René Schuhman and Frank Weiss, who are leveraging the new OpenCDE APIs. And the last one is David Ivey, who's going to show some examples of BCF uses in practice. So again, there's a lot of things interconnected. There's tools, there's standards, and when you use that QR codes that we showed earlier, you can find an overview as well on which phases can you use what and how does it all relate. So just one quick other QR code as well. If the speakers stay within time and you want to ask them a question, please use the Hopin platform. I'll try to monitor the questions. If they have time left, I can also ask them on stage. So without further ado, first speaker is Min Song and Rick Klooster. Please, yeah. So Min is from SBI International, but better known in this group as the company from Calvin Cam, probably. Rick is also Dutch. I really try to keep as much Dutch people away from the stage in this session, but Rick was invited by Min because he really did an awesome job. And both of them are going to present something about, I think, Hong Kong, The Hague, and Win Windows, right?
Yep.
All right.
Right.
Please welcome them.
Thank you. All right. So Amin from SBI, we are mainly located in the US, but we also do have offices in Asia and Europe. And Calvin Kam, like Léon mentioned, is founder of SBI. Is Mike working? Yeah. Founder of SBI. He is also chapter president of buildingSMART USA. So we are representing buildingSMART USA as well. And we are also representing BIM supporters group, a group of BIM consultants around the world. And actually, many of the use case examples that you will see today are collaborative work between the members of BIM supporters group, which Future Insight is also a member of. So, Rick?
Yeah, can you go to the next one? Yeah. Future Insight, Dutch company. I think a little bit not that well known yet in this area because we actually come from kind of a different environment. From the geo kind of view, we provide software solutions, smart software solutions. As you can see, the digital twins. That's where we started 8 years ago. We're doing large digital twins, for example, for the city of Rotterdam, The Hague, and a few years ago we also started doing BIM. We started with the permit checking, BIM permit checking case in Estonia, which we'll show tomorrow for the awards presentation. So if you want to know more about that, come back tomorrow. Today we're going to do some other cases where we implemented IDS to increase the workflow.
Okay. So yeah, today's topic is about information delivery specification IDS, but we will focus a little bit more on the actual use cases and proven applications rather than the background of IDS. I think you can look it up what IDS is on the website. But just a very quick introduction of what IDS is. It's an information delivery specification, a new standard that buildingSMART International has made in 2020. I think it's version 0.9 today. And it's basically a standard for creating a machine-readable specifications. Some of you might think we do have already machine-readable specification. You have rule sets within a model checker that you can adjust and customize. But the difference here is the intention of buildingSMART is really to make that machine-readable specification interchangeable, interoperable between different BIM software out there, and of course different stakeholders out there as well, so that you can export your machine-readable specification from one BIM tool to another BIM tool and import that specification into your software. So what you can specify with IDS standard is you can specify the entity types, the property types, and the values stored within the properties, and also the data types required for those properties. And this is something that we wish to do. We haven't done yet, but in the future, you should be able to link and leverage data that's stored in the buildingSMART data dictionary as well. So going into proven applications, so like I said, IDS is a fairly new standard within buildingSMART, but it is implemented, it is tested, and it is proven with actual examples with the Hong Kong case that I'll be talking about and the Hague case that Rick will be talking about. So before we go into the Hong Kong case, the founder of SBI, Calvin Kam, has prepared a brief introduction to the Hong Kong application here. I think the sound is not coming through. Can I start this again?
buildingSMART USA.
Thank you.
I wish I could be in Montreal with all my friends and the International Friendship Club in person. But due to family reasons, I can only join you remotely, and wishing you all a successful week. Coming to the information delivery specification, we work with a global team with team members, sponsors, integration managers, technical teammates coming from the US chapter, coming from EU, the Netherlands, Finland, as well as Asia, including Hong Kong. And what we're trying to do is to bring IDS in the forefront of being agile, being value-adding, being rapid prototyping. We work on the advances of understanding industry problems, as Min mentioned, trying to bring city-scale openBIM, OpenGIS at the forefront, trying to come up with repeatable process that we can start to automate, start to make the IDS to be repeatable, start to focus on actual BIM standards and actual requirements at the city scale that we can work with the existing IDS specification, while also contributing to the ideas and the future of IDS. And for the past 20 years, our team and we've been at the forefront of trying to apply open standards to bring value, especially focusing on the owners community. And so in this case, we also did not wait long, even though with COVID, we were focusing on specific value propositions, use cases, bringing the lessons learned in order to apply that and pioneer that to not only focus on IDS on a project-by-project basis, but to look at that at a city scale in which we work with about 150 openBIM files, being able to automate and prove and demonstrate how we can see real impacts of about 12 seconds per check. At the same time, we hope that this will pave a good foundation for us to work with the global community, buildingSMART USA, buildingSMART Canada, other chapters and friends around the world to work together and bring our infrastructure, our buildings, our city at large, all in the IDS and working alongside with other openBIM solutions. At this point, I'll turn it back to Min to tell us through other project details. Thank you all.
Thank you, Calvin. So the Hong Kong project here, the objective of establishing information specification was to create a BIM data repository that integrates BIM information, not only the BIM information, but also the GIS information and the terrain models together. And when you are integrating BIM and GIS information, convert those into open standards so that when they are stored in the BIM data repository, you can access those information with a consistent framework. But going further, the client of this project, the owner of this project, Lands Department, what they wanted to do was actually build a system that allows you to build applications on top of this BIM data repository, whether that's a 4D simulation tool or IoT digital twin. So the objective of the information specification for this project was really to make this BIM data repository, GBDR, scalable on the level of city, and make this a process from the left to right repeatable and make the information shareable between the stakeholders that you see on the right side. So overall, the ideas for this project, the information specification requirements for this project was aimed at urban scale BIM data repository. And these are some of the examples of the specifications that we had. And as you can see, they are not targeting individual projects. So they're not like building code checking. They're more like a general specification that is applicable across different types of buildings. So for instance, for the BIM and GIS integrated platform, the model should be very light. So in this case, the furniture objects should be excluded from IPC model. And once you have the GIS information, the terrain data, placing IPC model into the correct location is really important. So whether that IPC model is georeferenced or not, that is a type of specification that we had to deal with. So first we came up with these human readable specifications, and what we did next was convert that human readable specification into a machine readable specification in an XML format. And in addition to creating the XML file formats, we also developed IDS checker that imports IDS XML file into the model checker. And before storing the IPC models into the GBDR, the BIM data repository, the IDS checker was used to check the models to make sure that the basic hygiene of the model is there. Next, I'll show you a brief demo of the application. It's a cloud-based app. It's a web browser. So at the bottom, you have 4 different tabs. So on the left side, that tab is used to upload your IFC models. And after you upload your IFC model, the second tab, the GIS tab, is used to place your IFC model in the context of the map. So if your model is georeferenced, then your IFC model should be automatically placed in the correct location in the map. And what you're seeing on the screen is pretty much 100% open standards. So we are using openBIM, OpenGIS, in a CityGML format. And the data streaming method is also open format using 3D tiles. And when you click on an IFC model, it will fly you to the exact location of that model. So that was the first use case the information specification had to support. And this is the second use case that you see here, a 4D simulation at urban scale. So on the left side, you have coefficient metrics like number of jobs created per area of that building or number of construction workers needed per area of that building. And you also have the built area of the entire building. So those coefficient metrics were linked to IFC slabs. And those 2 use cases that I've just shown you, the 4D simulation as well as visualization, those are the use cases that the IDS checker had to support. So this is the IDS checker in operation. You see different check items from top to bottom, and we also assigned a certain weight. So for instance, a georeference at the top has higher weight than compared to other check items because it is relatively more important. So by multiplying the check item score with the weight, you come up with the total IFC IDS score. In this case, the total score is 131 point, with the maximum score being 300 point. So that's relatively a simple model. This is a more complex model with 25,000 3D objects. The item that's being checked is whether the model has a proxy object or not. So when you click on the button on the left side, it highlights all the objects that are proxy objects in the model, which is not a good sign. And also with the IDS checker, you can select multiple models at the same time and drive the combined score of those 2 models at the same time on the model level as well as each individual level as well. And after running this IDS checker, we tested this with 149 IFC models, and we have a dashboard. It tells you the IDS scores of different project types, IDS scores of different departments submitting IFC model to the data repository. And of course, it shows the IDS score of individual models. So with that, I will hand it over to Rick to go over the next case.
Thank you. Yeah, another example which we built for the city of The Hague. This is kind of the infrastructure we use. So as Min said, everything based on open standards, everything web-based. And we can use it, the IFC and the CityGML database to support all kinds of applications. The permit check, we're doing some experiments with a 3D cadastre, but also the digital twin. But in all the cases, it's important that these BIM files are predictable and according to some requirements. Otherwise, all the other stuff won't work. So this was the case for the city of The Hague. They actually started from the digital twin and they want to use the BIM files to update the digital twin. So they want a conversion from the IFC file into CityGML and then update the city model with that. That's kind of the idea. On the left, there are some specifications which are typically on paper now. So that's nice, but then how do you check it? Well, IDS, of course, can help over there. So over here, an example of a first version of the conversion. So on the top, you see the LOD0, just the ground surface, and then LOD2, LOD3, nice with windows, LOD4, the interior, which will actually work better in CityGML3. It isn't optimal right now, but this kind of works. But we also saw that there are still a lot of errors with a lot of models because they aren't modeled right. So then you get the windows are left, floors are not set up specifically good. So you need these models, if it's the translation or whatever. If you want to use BIM, we typically not focus on the standard building industry, but on governments who aren't using BIM at all. And there's a lot of potential over there. But then these BIM files should be standard, and not every contractor. There's a lot of difference now between the BIM files, and then it doesn't work anymore. So it should be predictable according to the requirements, and it should be easy to check. And they don't want to set it up themselves. It should just be a service, put it in, and then you get an answer if it's okay or not okay, or make the service available for anyone who can check themselves if it works. And that's really a key to implement this kind of technologies on a large scale for governments and that kind of organizations. And there's another nice example where we didn't convert it to CityGML. You can discuss if you would like to go to CityGML. You can also just use BIM in the environment for a lot of use cases. So here we just show the BIM design straight into the digital twin without converting it to CityGML. We just directly show it using 3D tiles, which is kind of a layered approach where we can define what you serve on which zoom level. And this way we can make it really scalable and show the BIM designs directly into the digital twin. And then you can, these are all projects we're working on, and you can use the BIM to assign new addresses to new buildings, which is now done using floor plans, permit checks, public participation. When the permit is in a certain case, you can make it available and show it to the public, and they can have a look for themselves. And updating the digital twin. So plenty of use cases to use it, but for all the use cases, you need good BIM files. And then a last one, a little bit more technical, but it's to show a little bit more how detailed you can go. An example of a test with a wooden frame. Here's the XML, where we define the BIM requirements. Now we can open the design, just a wooden frame, which is to test the checks. Here you see some results. This is just the core. And here we focus, the red ones are wrong, the green ones are okay. Now we zoom in on a certain part of the model, which is okay. You can see the different property types. The color should be defined with a RAL color. So all this stuff you can define and then also automatically check it. Okay. Here's an example of a property which you can also link to the bSDD. So then that's the way you can connect those two as well. And then maybe a last one. Here you see the thermal transmittance value should be between 0.5 and 2.1. And when you really go into detail of the model, you will see over here that it's 1.3. So that's okay. So there's a lot of possibilities over here to just automatically check all these things before you do all the other stuff, because otherwise you get false results and then it doesn't work anymore. Back to you.
Okay, thank you. So business value of IDS, mainly focused on Hong Kong use case that I've explained before. So with the process metrics, this was what the government agency Lands Department was able to achieve. So they used 8 sets of open standards for setting up this system, not only OpenBIM IFC, but also CityGML and other open formats for streaming the data like 3D tiles. And they developed 10 machine-readable specification, basically the IDS XML files, and also the IDS checker that is capable of reading IDS XML file and check the models before storing those models in the GBDR, the BIM data repository. And we tested the system with 149 models, and for checking each of those models, it only took about 12 seconds. And using that process metrics, the client, the Lands Department of this project, was really able to accurately, assess their current status in terms of model hygiene, and then establish target values for 2025 and 2028. So with the maximum score of 300 points for each model, their target was to achieve 200 points for the building sector models and infrastructure sector models. And not only the high-level, specifications, come up with a detailed strategy for each of these check items. So for proxy objects, the score was relatively low, was 63%. But the goal of the lands department was improve that to 90% over the course of next 5 years. And one of the detailed strategy is to use IPC 4.3 framework. So with the IDS checker, the IDS checker enabled the owner, the client, to really quantify and assess, align, and target and generate the business values for the lands department, the client itself. Okay, thank you.
Thank you. So these guys will be available for the rest of the week as well. And I just wanted to add that these are really good experts in mixing all kinds of different standards, CityGML, IFC. Yeah, if there's any other questions you have for them, please feel free to find them. So thank you again.
Thank you.
Next speakers are Stijn and Jan. Where's Jan? Sneaking from the back. Yeah, so Stijn and Jan are, so Stijn is a BIM process manager at Volker Wessels, one of the largest contractors in the Netherlands. And Jan is the biggest risk taker of this whole summit because he is going to be doing a live demonstration. So as we all know, in this environment, some of it will fail, but please bear with him. Jan works for Digibase, which is a part of the Volker Wessels group. Both of these guys have been very instrumental in finding a product market match for the buildingSMART data dictionary for the bSDD a couple of years ago. Then they didn't, their engagement was a bit less. And a couple months ago, they called me. So these were the guys that called me and said, yeah, we did some experiments, we tested, we have some questions, we want to know if we did it right. And then they showed me this, which is really, really awesome. So if you are ready, you need to clicker, of course.
I have my own
perfect. Our laptop, yes, of course.
And our own clickers.
Please welcome them.
Okay, thanks. Yes, the screen works. Hello, everybody. My name is Stijn van Schaijk, and I'm here today with my colleague Jan Brouwer. We work for Volker Wessels, which is a Dutch-based contractor. We also have some subsidiaries in the UK, in Canada, and Germany as well. And actually, yes, like Leo mentioned, we today have prepared some live demos and some, which we're going to show you from our own device, actually. We're going to present some live demos of the usage of the buildingSMART data dictionary. Last few months, we've been experimenting actually with this. A bit of a column, so try another place to stand. Last few months, we have experimented with the bSDD actually, and we developed some plugins ourselves. So we developed a Revit plugin, a SketchUp plugin, and a Trimble Connect plugin for the bSDD. And we did that actually to fully understand the potential of the bSDD. And actually, our conclusion, and I'm starting with the conclusion of our presentation actually, the conclusion of this research was that it could definitely help us in gaining better and more structured information in our BIM models at the moment. So we will come back, in this, we show you the live demos in a second, but I think it's good that you also understand our company and our process as well, so that you can place the buildingSMART data dictionary in the perspective of a general contractor. So as a general contractor, we are a group of multiple companies actually. We work for the construction and real estate division, which has around 35 different companies, and all those companies have their own specialism and their own part in the process of a building life cycle. So we have real estate developers which start our projects, of a lot of our projects. We have general contractors, which then can make them. We have an MEP company, which is part of this process as well. We have some highly advanced factories and manufacturers, And we also have an asset management company. So we can be fully included in the building life cycle, actually. And Jan and I both work for a company called Digibase. Digibase is one of those 35 subsidiaries of Volker Wessels. And we help all the other 34 companies actually in implementing BIM and digital workflows. So with working at Digibase, I think we have a pretty good overview, helicopter view of our own internal process, but also about the process in the Netherlands, actually. And then we keep track on all the developments regarding BIM and in the Netherlands and also worldwide, actually. So with that, we help our companies innovating and structuring their BIM data, actually. And what's really interesting, what we see in the last few years, is that we actually at this moment in the Netherlands, we pretty good know actually what must be inside our BIM models in terms of information, in terms of geometry, in order to be able to reuse those models actually. And I remember when I personally started 10 years ago as a BIM manager, we asked our clients and we asked our subcontractors and we asked our partners, okay, what kind of information do you need in the model? And how should we model it so that you can reuse it? And then they all said, okay, I actually don't know. What's this for kind of question? You're asking me about the information. And now it's the other way around. Our clients, our subcontractors, they actually give us requirements and they say, okay, please put this in the model on this specific place, in this specific parameter, so that I can automate my own process actually. So all those requirements are stored in like human readable formats. I just learned that we also have computer readable formats. So in the most projects we do, we get the basic requirements actually. But we also have some very specific documented requirements from our subcontractors. So an example of this is that we, in the Netherlands, a group of prefabricators, a group of factories, they actually joined each other and they said, okay, we make an IDS for prefab or for constructual concrete floor elements. And they describe very, until the last detail, how those floors should be modeled geometrically, but also in terms of information. And if you deliver them this kind of information, they actually say we can give you a discount on our price because we can automate our own process internally. So if you help us doing that, it can cost you less. We also have the same in Netherlands for steel. We have the same for facades, the same for constructional walls, the same for wooden windows. These are all on national level, but we also have some very specific requirements for our BIM use cases for our own company, actually. So we have some requirements for very specific use cases as well. And what's typically done at the Dutch BIM project is then that when we sit together with a project team, we determine the BIM use case for that specific project together with the client as well, and we store, we search in all those very specific IDSs, and we combine them in a large spreadsheet, and we say, okay, this is the IDS or requirements for our specific project. And if you dive into one of those specific requirements, you actually find out that you use some different domains and different classification systems in order to be able to use your BIM model. So an example is this is our internal requirement for creating a material passport. I'm not sure if material passport is a common use case for BIM models here as well, but we use a material passport in order to see what kind of materials and resources are used in detail in our models and in our projects. So we can use that information to track our sustainability goals, actually. We will show this use case later on live as well in the demo. But for this specific use case, we need an international standard like IFC as a data model. We use some national classification systems, and we use some own local private source list, actually. and so the combination of those source lists actually make it work for us. And if you then go to one of our projects, it looks like this. We go to sit on the table together with all the partners, and we determine the requirements for that specific project. Then we ask all our partners, okay, can you please model the IFC models in your own preferred software, of course, export the IFCs, and then upload it to our common data environment. In this environment, we bring all those models, of course, together, and then at that point, everyone in the project team can look at all those models and can reuse it for their specific use case, actually. And what's interesting is that, what's interesting is actually that at that moment, a lot of things, usually go wrong. We have so many requirements for that one BIM modeler, or those few BIM modelers on that specific project, that those BIM modelers actually are saying, okay, for me at this moment it's too much to put all this information in the model. So this is really, and this is actually a good thing, because we now know what must be in the models, but now we have to find ways to help those BIM modelers actually in putting the information on the right place. So the BIM modelers and those parties actually say, okay, this is too much for me at this moment. And also they often do not have that specific knowledge to put in the right information on the right place. So that's also a thing with the risk. And if they do put the information in those models, it's still a lot of manual input. They of course have their own BIM libraries, which are pretty advanced for all the standard stuff. But if you ask for specific requirements, it's difficult for them. And then the last thing which is difficult about this process, where it goes wrong in terms of usability, is that per software and per modeling company, the details in the IFC are just different. Yeah, right. I think that's a recognizable thing. It's just because there's a lot of manual input, all the IFCs from the different software packages have just other export settings. So if you look at this data, all the details are different. And in a lot of those requirements and use cases I talked about, the details actually matter. We will show you that also in the live demo in a few minutes. So we were actually, a few months ago, we were searching for a solution, and we came actually up with two main questions. One is, can we assist those modelers in putting the right properties with the correct input on the right place so that the details will actually be correct? And can we also give all those other people involved in the process the tools and the accessibility actually to actually also add that specialism, their specialism, to the models as well? So our new proposed workflow would then actually be, could we develop, and we actually started developing our own solution. So we started developing our own database where actually we combine standards and requirements and source lists, etc. And we were actually trying to, and we did that as well, we made plugins for some software to actually connect this database to the software. And we would also connect it to our CDE. That's Trimble Connect, by the way. So we were actually searching for this solution. And then we thought, okay, maybe the buildingSMART data dictionary can help us with that. And it actually worked pretty good. So let me get back. So in a minute, we go to the live demo. But for that, we use a sample project. We took a very simple project, actually, because for us, this presentation is not about advanced buildings, but it's about simple software demos. So we also have a simple demo project. It's about our conceptual housing project, and we take a little fragment of this model, which we show you in a minute. And we do that by giving you actual two examples, which we place here on our project timeline. So our project usually starts with initiation, of course, design, engineering, production, construction, and in the end, in use. And the first use case we're going to show you will take place in the design phase. And the second, and where we actually will focus on those specific usage of models, so cost estimation, visualization, and creating the material passport. And the second use case we will show is about adding door production data to our models so that our own factory can produce it automatically or semi-automatically. So this will be my next slide before Jan takes over. Before we started this developing, actually, we were wondering three things. We were wondering, okay, how would look our object definition on a bSDD? So that's also what we're going to show you today. We wondered ourselves, could we generate exact the same IFCs with exact the same data from different modeling tools? That's what we're going to show you. And we wondered ourselves, could we connect the bSDD to another tool than a modeling tool? So in this case, a common data environment, which is ThermoConnect for us, to give the experts actually the tools themselves to add properties to the model. So those three things we're actually going to show you also right now.
Yeah, I will first take you to the bSDD search tool, where we started to create a couple of objects, recipes that are part of the demo model. And I will first search for the test environment of the bSDD, and here I can filter on our demo objects. And the one that we will focus on is the canal plat. It's the hollow core slab. And here you can see a summary of all the information available and properties that we set for the object. But it's not completely, not everything is here. So we go to the raw data. It's maybe not the best place for these kind of things, but here you can see we say this floor slab has to be an external element, and it's always set to true. It's load bearing, and the fire rating has to be set. And part of the main classification object is also a material classification. It's a generic concrete in Dutch, and it has an IFC type set and an NLSFB code. That's our main classification code in the Netherlands that we use for a lot of things. So I'll first take you to the.
Sorry, Jan.
Oh,
I think we really show you the raw data and the details because it's in the details for us for this presentation. So that's why we show you the raw data as well.
I think it gets more interesting when we get to Revit, because we can see the same things here. I have the model that Stijn just showed, and when I select this floor slab here, you can see there's not much to it. It has a generic material and only an IFC type set. And we created the plugin with a web interface where we can search for the same floor, and we get the same data back, but a little bit more formatted as properties. You can see here the Volker Wessels classification, the material, IFC type, and the codes. And you can also see you cannot change the external and load bearing properties because they are fixed. And for the demo, I will add a 60-minute fire rating. So when I close this, it should be set in the object. So we have set here, including an IFC description, also a lot of tools. So from this we can export. And then we will go on to the next plugin. That's the first thing that we started on. The same plugin, the same window in SketchUp. And if we look at the model here, some objects do have properties, but this floor slab is completely empty. It's just a box, nothing more. And when I look up the floor and also at the fire rating here, it downloads all the classification systems from the bSDD as native SketchUp classifications and sets the material to generic concrete, adds the classifications to the model, and also sets the fire rating to 60. So this one's also ready to export. And for this demo, we already uploaded the files to Trimble Connect. And you can see the models next to each other. One is the SketchUp model and one is the Revit model. And when we select these floor slabs, you can see that the selected objects, they have the same properties. We can see here the LSFB code, the description is external, fire rating, and material. So that's that's the main thing that we looked into for this.
This is just halfway the presentation, so we have more things to demo. But maybe what's good to emphasize a bit more is that you saw the difference between the Revit and the SketchUp model actually. And if you look into the models in detail, there are differences, but the requirements which we asked for the project, they were exactly the same. So as those models come into our project, we could use those for the specific use cases we actually decided for that project, not depending on a specific software. Jan just showed you the Holocaust lab, but we also did some more focus elements. So all the green objects which you see here are actually that one we will be showing in the demo as well. Or we will not show how we modeled them, but we will show you how we can reuse those models actually. So for the first showcase, actually, we exported this model and we put it in. Can you start the? We put it in our cost estimation software, which is actually Vico Office, a Trimble product, which you can see right here now. And what you are seeing is that we imported the model, and the objects which were classified correctly by use of the bSDD can be estimated directly within the software. All the other objects, are not recognized by the software automatically, so the cost estimator has to do some manual work to classify them themselves. So within the software, it's possible to make cost recipes actually, and that's what you're seeing right now. He's recognizing the objects based on all the classifications and the information. It's combining it with a cost recipe, and based on that, we can make what we call work packages of work with materials and quantities, etc. And that one is used for our cost estimation and also for quotes with our subcontractors. So to give you an overview of how we use those models. We go to the next use case for this specific project. Can I click it? Yes, there it is. It's about rendering and visualization of the model. It's maybe not the most impressive use case, but it's to show you the diversity of the use cases we have within. So this is a program we call, which is Twinmotion, where we do a lot of rendering in, and we import the same model, and you can see very clearly that the objects which were classified good, the materials were recognized by our render engine actually, and they are rendered as you can see. And then the last showcase we have is about creating a material passport. So that's what you can see right here. The objects are recognized and because there are still some conceptual objects. They're not modeled in very detail. We have this tool we developed ourselves to actually find out what raw materials should be in those objects actually. And by using this tool, we can very quickly create a material passport of a conceptual model, which we then can use actually for our sustainability dashboards. There's also an official material passport document, which is then automatically generated, which can be provided to our client, for example, of to other people who are interested in this during the process. Okay, then we go to our next use case. Actually, what we just showed you is the connection below, so between the data dictionary and the modeling tools. And what we're now going to show you is the connection between the bSDD and our CDE, which is Trimble Connect. For that, we have the use case, which will be which usually takes place in the pre-production phase, where we're going to add specific production data to our interior door. And for that, we use those kind of source lists. A few, of course, international IFC, the NLSB is needed. We have two local source lists. One is a default list of how you name building stories. It's pretty obvious, but we have it. And we have our private list, which is which are the door production parameters. So those are specific for this factory actually needed. So this is how it looks like. We're not going to show you this again on the bSDD, but this is how it looks like when it is published on the bSDD. We did not publish all of the private parameters, but some just for this example. And Jan is now going to show how we can add that to this information to the model. So imagine you are a project participator. You're not a modeler, and you want to add information to the model because you want to prepare the door for the factory, actually. That's what we're going to see right now.
Yeah, here we have the same model that we just showed, and you can see there are only IFC properties present, and we created this almost the same plugin for Trimble Connect with the same web interface. So if I look up binnendeur, here's our Volkerwessels binnendeur. And you see the IFC type lights up. We have the door. And I will fill in a couple of important parameters. A door number, maybe the story. That could also be done in another way. It's a single door. Yep. And some more properties will be important for the production, but when I say apply, it should update the list on the right. And we see that the door is on the CDE is extended with additional parameters. And the most important one is the property set for our manufacturer that needs to know these specific parameters. So this shows that someone without modeling software can also add their own specialist information to the model. And then the last is to extend the IFC model, the original one, and export that back to IFC and that to the manufacturer. And because it takes a few seconds, I already got this one, so I will download it from here. And then I will show in Solibri that these parameters should be in the IFC file. So yeah, that's the second main demo that we wanted to do. Yeah.
Yes, next slide. Yeah. Okay, then we wrap up the presentation actually. So in the beginning I told you we were searching for a solution to, one, assist the modeler, and secondly, give more people in the process the ability to extend models information, and not only in a regular way, but in a consistent way, so that the model could actually be used for specific use cases in the project. And I think we found that in the bSDD, and we're actually here to talk with you guys about how we should take this to the next level, how we really could implement it in our processes, because we developed the software ourselves, but we're not a software company, we're a general contractor. So I was happy to hear this morning that Autodesk already had a bSDD plugin in beta. We weren't aware of that, but really curious in trying that one as well, and sharing our knowledge about what we learned in this project actually. So if you want to learn more, I saw that there are especially some specific sessions about the bSDD as well tomorrow and on Thursday. What's also a recommendation is that you can join our next presentation on Thursday as well. Then we will be on stage with another colleague, Nick, where we will present how we do a typical BIM project in the Netherlands. And what's really exciting about this project that we will publish all the data, all the BIM data for this specific project. We will officially publish that as an open source or an open data set. So I hope to speak to you then. Thanks.
Thank you so much. Yeah, so again, these guys are here all week as well, and I have a couple of other cool presentations. I think what's really nice to see on this presentation is that this is a general contractor who invested in a Revit plugin, a SketchUp plugin, and a Trimble Connect plugin, and all think that's worth because that improves their processes and efficiency so much they would make that money back easily. So thank you again. It's really an awesome presentation. Yeah. So in the spirit of live demos and experiments, we are now moving towards a live presentation coming from Germany. I'm not really sure how we are going to do that. Are we already online? Ah, perfect. I see Frank and René patiently waiting. It's probably almost bedtime for you guys, so thank you so much for staying with us. I was asked to do the intro as short as possible. So Frank Weiss from Oracle, Aconex, and René Schuhman from Vicon Hoogtief. So please take it away. You're on screen.
Hi, everyone. Can you hear me well? Okay, I take that as a yes. So, hi, everyone, and welcome to the session. OpenCDE Document API, game changer for project management and more. So we have the honor to speak to you in the next 10 minutes about one of the most recent new BSI standards, starting in practice. So let's go. After the quick intro, we will tip on value and motivation. We'll dip into practice examples and close with further takeaways for the audience. Allow me one word about the company I'm working with. Oracle Construction and Engineering is known for market-leading products. Just to name two, which are probably familiar to the audience, Primavera P6 or the Aconex Common Data Environment. Oracle is a long-year SAC member and contributor to open standards, and we are really excited about two BSI initiatives in particular. So we have been leading the BSCF group together with other vendors for a couple of years now, and initiated and leading the OpenCDE Document API working group amongst 12 companies over 2 years of mutual development. So what's the problem we are solving, and how do we want it to create value for users? Let's start with a simple problem which most of us are aware. lots of applications are used on projects, design authoring, validations, common data environments. We can see a selection of typical products on projects, and there are probably many more. So that leads to challenges like there's just more effort for the exchange of that data because of the different tools. There are a lot of delays because of manual work or processes are breaking up. Many mistakes happening because there are many versions of the truth. And there's higher cost because of the bad quality of data. So we all know how painful it can be in practice. So for example, the simple exchange of files. We wanted to cut out the non-necessary steps now with the goal to reduce the number of steps, to minimize manual effort, and also to save time across multiple exchanges per coordination cycle. And I think we all have enough imagination how many of those we have in full-blown construction projects. So how to imagine it? So architects and planners, they send their partial IFC models, for instance, to a common data environment. Based on the APIs, they send it to their validation tools. They have their data exchange where they run their typical federation of models, run clash testing, quality topics, and so forth. The issues will be via the APIs being sent back to the common data environment. But in addition now, also the models can now also be exchanged via the API to help for the coordination meeting. The whole thing will be round up when those comments and remarks go back to the teams. Now, let's move to some practical experience and hear from René how the OpenCDE Document API can be a game changer.
Yes, good afternoon. Thanks, Frank. In the next couple of minutes, I would like to briefly show how we use the OpenCDE API on our projects and why it is so important for other software vendors to implement such an standard in the next near future. On the next slide, you can see an example data and systems architecture from a project in infrastructure sector in the United Kingdom. On the top, you see there is always a data production that comes out of our business processes. And we have this data production, of course, in all phases in our projects in design, construction, and operation. Important for us is that this data production or data creation is going to be controlled, and we prefer to define data structures in order to get those data properly on. In the middle, in the red box, you see the common data environment. So all data that is going to be created, of course, goes to be shared with other stakeholders on the project on a central CDE. And from there, we take the data again to interlink data coming from different sources to each other. Why we are doing it? To do project controls, you need data from the cost area, you need data from your scheduling, and you need data from maybe your designer. And all that need to be interlinked. And in case you have that, then you are in a position to do data control. We also see that there is not maybe only one common data environment. There is probably one from the contractor side that is going to be used for design and construction. And there's another one from the owner's side that is more focused on the operation and maintenance phase of this particular project. If we look to the next slide, I brought you some of the examples. So we say that on bigger projects, mega projects, we support more than 200 different, we call it functions, or you can also name it business processes. That can be processes like your project controls, it can be quantity takeoff, it can be clash detection or whatever, 200 different functions, business processes. And we see more than 40 different software systems or authoring systems in place. Most often this complexity is not really shown in our projects. It's invisible because nobody is really interested in to see that. If you want to do digital twins in future, if you want to bring data together on a CDE or maybe interlink them afterwards, it is important really to understand how your 200 different business processes are going to be managed and what systems are going to be used in order to decide what is the best approach to take data on and how to structure it and how to link it. If we go to the next slide, we see one solution we have developed in order to quickly interlink data to each other, so to say, standardize the way how we're going to do it. We call the system ORIS, and this is a specialized system where we bring data from different sources into one central database based on predefined rules and based on a standardized data structure. And you can see that we consider here the planning or design, construction, and operation phase, different systems, different authoring systems where we take data on. The next slide also gives a little bit more precise example what can be those authoring systems. There is CDE, of course, not only an Oracle or Econex CDE, but also maybe Bentley, ProjectWise, or others. But there's a cost management system, there's a scheduling system, there's GIS, there are plenty of different systems. And our focus is to bring the data that is going to be created or stored in those systems together. And the next slide shows that we have not only data in one particular CDE. Most often in bigger projects, on the bottom you see the different business processes as an example. And you can see very often that the designers have specified a CDE for data exchange during the design process. And if it comes then later to different business processes, there might be another CDE. So it is important not only to predefine and manage how data is going to be into a CDE, but it is also important to make sure that data are going to be exchanged between different CDEs on the project. And the next slide shows that how we manage it. So we have the project I mentioned in the UK, for example. We have 3 different CDE systems involved. And for us, it is important to have an openCDE API really to interlink and exchange data between the different CDE systems and to bring that all together into one central database, because that is what we do to interlink certain data and to allow proper processes. Because at the end, what we want to do is to make project management even better. And this is a data visualization side, so to say, that people need to, let's say, work with the data. Doesn't matter which authoring system is behind, because a project manager cannot really look into 40 different systems. He needs one dashboard to take data on and to make quick and good decisions based on that. And therefore, it is highly important, really, that we have this CDE standard to exchange data between the different systems. That's it from my side, Frank.
Thank you. So what are the further takeaways for the audience? So number one, we ran successful customer engagement programs with over about 10 companies, testing it with very good feedback about it. Our solution, the Oracle Aconex, fully supports the OpenCDE Document API, including all plugins to other products. And for those who are more interested in more details, there's a demo on the buildingSMART YouTube channel in 3 minutes, and the documentation, of course, on the GitHub. One final note, we would like to demonstrate a specific project in more detail at the next summit in Rome. So that's an idea to do that really on a specific one, which we do not want to publish now, because we work with the customer if he is okay to really demonstrate that. We are extremely excited about that new standard and would like to encourage everyone to start using it, and vendors who are listening here to implement it to their specific product, because then we can simplify the day in the life of our users and create more value by open standards. Thank you very much for your attention.
Thank you, Frank René. We're still not sure if you can hear us, but you got a warm round of applause. Thank you very much. So next speaker is David Ivey from HOK. Many of you know him as the leader of the building room, of course. He's here as a representative of HOK, giving us some examples of how. Come on, David. Yeah, I hate inefficiency. Come on, move.
Can you hear me? Oh, okay.
Yeah.
Do we really have 10 minutes?
I have no idea how much.
schedule?
I don't think we're on schedule, but
Usually when someone
You've got
says
10
you
minutes.
have 10 minutes and you're going last, it means 60 seconds. Keep it tight.
I still have a couple slides after you, so no worries.
Okay, I'll keep it quick. Yeah, I don't have much personal stuff to share. I'm Dave Ivey. I'm with HOK. I work in the Chicago office. I'm going to go over to the neglected part of the stage here just so I can see these people. A note to you, Leon, I do enjoy a Pannekuchen. We have a place where I grew up called the Pannekuchenhuis. They bring the Pannekuchens out all inflated on roller skates, but you can look it up later. We can talk about it tonight. So a little bit about us. HOK is a global AE design firm. We have over 20 offices around the globe. I happen to be in the Chicago office. And obviously, you know, as a large firm, and really that's true all the way down to any size firm, you know, we're interested in interoperability, we're interested in productivity and efficiency and all these things. And so this talk, you know, I'm not going to do a live demo, and kudos to everybody who did them and got through it. That's always a big plus. But this is going to be a little more qualitative talk. I want to talk a little bit about value and how we see BCF specifically bringing value to the processes that we have in-house. So why BCF? You know, I initially put a question mark up there, and then I thought, well, it shouldn't really be a question, right? It's really more of a statement or an explanation of why we're using BCF. So I left the question mark off, but you know, BCF has a lot of, like any open standards, things going for it. So one is it's open and it's interoperable, right? So that automatically expands the pool of people that we can work with, right? So we're not really tied into just those people that use the very same tools that we use, right? So having a larger talent pool to choose from, you know, adds some efficiency and some ability to our projects that we might not have otherwise. It's also extensible. So I think a few people mentioned, or someone said, you know, if you don't like it, you know, the way BCF works for you, whether you're using something like BIM Collab or another tool, you can make your own tool, right? Based on the open standard. And so it gives firms the ability to say, oh, well, you know, I wanted to do a little bit more. And we sort of did that thing a few years ago, and we have a tool that we're kind of working with that does BCF. Happens to be free, which is always cool. Not a lot of free tools out there, but BCF is one of those. And then, you know, we'll talk a little bit more about our process and how it integrates into everything that we do at HOK. So BCF at HOK is really kind of a smaller part of a large process for clash detection that we do. And generally speaking, we want to be looking at our models, and this is design level model-based coordination, right? So we're not doing construction coordination. We leave that to the CM and their crew. But we want to provide models to those people at some point in the future, right, that are as well coordinated and error-free as we can. And, you know, when we talk about value, I think one of the things that can be kind of difficult in talking about clash detection and tools that are associated with that, like BCF, is that it's kind of hard to quantify sometimes things that you didn't do, problems you didn't have, money you didn't spend to solve a problem. And so when we talk about clash detection, automatically there's value built into it, because if we do it early enough and we do it often enough, then, you know, it results in maybe something like fewer RFIs and questions from consultants and the construction team. So a typical workflow for us at HOK starts with a kind of a weekly meeting, right? And BCF will come into this near the end of that, but we'll start by collecting IFC files, and that's, everybody should know what IFCs are. It's kind of BCF's cousin, or maybe it's the other way around. But we'll create IFCs, say, on a Tuesday. We'll collect those from all of our consultants, and then on Wednesday we'll run a bunch of clash tests, and we use a variety of tools to do that. Most people know Celebri or Navisworks, so we'll use something like that to run those tests and kind of prep all of that stuff for the next day, which is a meeting with all of our consultants, right? Sometimes it's in a big room, sometimes, especially now lately, a pandemic world that we live in, it's an online meeting that we have, and we get people together and we start to go through these things. And so as we go through them, one of the things that we're looking to do is to build efficiency, if you will, looking at clashes, because we're not really concerned about every single clash that we find, right? We start with fairly loose tolerances and kind of work our way down, but we're less concerned with identifying every single thing as we are at identifying groups of issues that are combined together, right? So we want a duct that might cross through 10 or 15 beams, not as 10 or 15 separate issues, but as one issue that we can resolve. And so when we start to put these things together, that's where BCF becomes really helpful for us. So what we do is we sit down, we have a large meeting, we look through these clashes, and some we just kind of throw away, right? Sometimes the consultant will say, well, we already addressed that, or that's simple, we're going to do that right now while we're on the call. And then other things are more involved and require some thinking and some planning and some rethought. And so as we use our tools, right, we'll put together some presentations and we'll write a BCF report out so that people can then take that BCF file into their tool and start to look at, how they resolve these things. So just kind of some pictures of the process and talking through about it. We, like I said, use a variety of tools to look at it. We do projects that are small, like just a few thousand square feet interiors type projects. Sometimes they have a small mechanical component, or maybe even some kind of structural component to them, all the way up to, institutional work, aviation hubs, transportation hubs, all kinds of stuff, hospitals. So the complexity of what we get out can be very big, and that kind of drives what tools we use. So sometimes we use BIM Collab. One of the nice things about it is it has its own free standalone viewer. So people who might not be able to use the BCF file in their own tool can open it up and look at some of these things and kind of work side by side with their tool to figure out how to resolve these things. Other times, like I said, we want to kind of group things together. So people who work on our tools, we can take the BCF tools and take this specific example is a tool that we've been developing in-house at HOK that allows us to do a little more with the clashes that we find in terms of grouping them together and creating a separate single issues for them when we're talking about 5 or 6 pieces that may be problematic at any given place. And then, same kind of thing, we're creating these reports to hopefully give to someone else that gives them the ability to resolve these issues in situ, like in their tool, and then get back to us. And then we repeat the whole process again the following week or the following 2 weeks, depending on the project and the nature of what we're doing. So really for us, BCF, I thought about it at the earlier session when we were talking about sustainability, and I thought, in a sense, BCF is kind of a sustainability tool as well, thinking that, when we correct something in the models based on model-based coordination, before we get an RFI, before something's built in the field, that means something doesn't need to get torn down. That might mean that a consultant or someone doesn't need to drive back out to the site or fly back out to the site. And so, in a sense, it's kind of a sustainable tool as well. So I think we find a lot of value in that, right? In efficiency and productivity, and in the ability to basically solve problems before they become physical problems in the real world. So that's really it. The tools, like I said, are free. They're out there. I think Leon mentioned that we had a good primer on the hub somewhere, or somebody mentioned it. So you can find more on the buildingSMART hub to address all this stuff if you want to see more details on how the tool works.
Thank you, David.
Yeah.
That was actually well within time. Thank you so much. Again, I like the efficiency here. So I've got a couple of closing slides. but not enough time left. So let me start by mentioning the most important thing. After I stop talking, we are on a break. We are going to the third level. There's coffee there. And we're going to be back in this room at 4 p.m. So I had a couple of recommendations on sessions to go to in the next couple of days if you want to learn more about all of these different technologies that you saw today. But I'm not going to go through all of them, and some of them you already saw, so Nick and Stijn are already there. So there are 2 final slides that I did want to show you, because what we saw today were actual demonstrations of actual use of relatively new things. The new bSDD, new IDS, OpenCDE APIs. And we always talk about this chicken and egg problem within our community. So you need to have the standard first, and then implementations follow, but you need to have the implementation first, but then the users but you need users, because then otherwise how can you make the standard? So there's always this, we talk a lot about this chicken and egg problem. So in the spirit of how I started on this fighting assumptions, when you actually Google this, you know that the egg was first. There's really no question about it even. The egg was first, and even if you have doubts if it was a chicken egg, there's even a chicken egg was first before the chicken came. What you saw today were the eggs. These were the people that went out on a limb, took a little bit of a risk. Live demos was actually a big risk. Thank you again for that. Took a little bit of risk, just looked at it, dove into it, and used it, and found a real lot of value in the solutions and standards from buildingSMART. So I invite everyone to do the same. I invite everyone to be an egg, or else you would probably be a chicken. I see you all at the coffee, third level. Thank you very much.